Hey guys, Mrs. Cutting, and this is part 2 of the lesson 5 video. So you just finished with your talking partner doing section 5.3, what are equivalent ratios. Before I talk about that, I just want to go back up here for just a minute and talk about equivalent ratios. So when we were finding in our tuna casserole, which I still think is gross by the way, when we were finding how much of each ingredient we needed to make twice and half and 5 times and 1/5, there was a number that we could multiply each of these numbers in our ratio by to give us our new ratio. So when we were doing twice the amount of the casserole, I didn't multiply 10 by 2, 1 by 2, and 3 by 7. I multiplied all 3 of these by the same thing. And then down here to do half the amount, I could have divided, but dividing by 2 is the same as multiplying by 1/2, so we're going to always find something that we can multiply by. So down here, to find half the amount of casserole, I did 10 times 1/2, 1 times 1/2, 3 times 1/2. So I multiplied by the same thing every time. To find 5 times, I multiplied by 5, and then to find 1/5, I multiplied by 1/5 each time, and that made those equivalent ratios. Okay, so back to the part that you just did. What are equivalent ratios? So is the ratio 15 to 12 equivalent to 5 to 3 and 10 to 6? It is not. If I do 5 to 3, I can't make 15 and 12 by multiplying both of these by the same number. So 5 times 3 gives me 15, but 3 times 4 gives me 12. So you can't multiply 5 and 3 by the same number to get 15 and 12. And that is how we know that they're not equivalent ratios. Okay, so then the top of the next page is the ratio 30 to 18 equivalent to these. Well, my original ratio was 5 to 3. If I multiply 5 by 6, I get 30. If I multiply 3 by 6, I get 18. So yes, they are equivalent because you can multiply 5 and 3 by 6 to get 30 and 18. So if you don't have a complete explanation for this, pause the video, write it down. So then for number 3, give 2 more examples of ratios that are equivalent to 5 to 3. So I can pick any number to multiply 5 and 3 by, and it will give me an equivalent ratio as long as I multiply both 5 and 3 by the same number. So I'm going to do times 3. So 5 times 3 is going to give me 15. 3 times 3 is 9, so I'm going to do 15 to 9. And I'm going to do times 5. So 5 times 5 is 25, and 3 times 5 is 15. So I know that both of those are equivalent to 5 to 3 because I was able to multiply both numbers by the same thing to get that. So you could have done 500 to 300 if you wanted to multiply by 100. You could have done 50 to 30 if you wanted to multiply by 10. Whatever you want to do, as long as you're multiplying both of these by the same number. Okay, so how do you know when ratios are equivalent and when they are not equivalent? Basically the same thing I just said, but now I'm going to write it down. They are equivalent if you can multiply both numbers in the ratio, that's a number sign, not a hashtag, both numbers in the ratio by the same number to get the other ratio. Okay, so pause if you need to add to your explanation here. And then number 5, write a definition of equivalent ratios. And your sentence starter was a ratio is equivalent to A to B when, and I am not going to fill that in because yours does not need to be exactly the same as everyone else's. Okay, so then the next part that you're going to do, I'm going to switch back to my slide. There we go. Okay, so with your talking partner, you're going to get a blank piece of paper and you are going to create a visual display, also known as a mini poster, about equivalent ratios. So your title is going to be equivalent ratios. Feel free, don't just use pencil, like, make it kind of fancy as much as you have time for. You can use the colored pencils, the highlighters in your basket. If you have your own coloring supplies, you can use that. So you're going to have the title, equivalent ratios, your best definition of equivalent ratios, so you can use your answer from number 5, that sentence that you completed. And then I am assigning you a ratio to use as an example. So if you are in the blue row, you're going to use 4 to 5. If you're in the orange row, you're going to use 3 to 2. Green row, 5 to 6. So make sure you write that down before you close out of the video. Okay, thanks. And then at least 2 examples of ratios that are equivalent to your ratio, an explanation of how you know these examples are equivalent, and then at least 1 example of a ratio that is not equivalent to your ratio, and an explanation of how you know it is not equivalent. So you're going to make your poster. You're going to put both you and your talking partner's names on it, and then you're going to turn it in. And then there is 1 more video that is going to go over the lesson summary, the cool down, and I think that's it. Okay, just a couple more things that I want to talk about just before I close out, this video. So we know that when we're making a recipe like the tuna casserole recipe, when we double or triple a recipe, the ratios of the amount of ingredients in the mixtures are equivalent to those in the original recipe. So over here, when I doubled the recipe, I was still making the same tasting tuna casserole because I was just doubling everything. So same thing here, I was just multiplying everything times 1/2, but I still am using the same ratio of ingredients, so it's still going to taste the same. And I think that's it for my summary for now. Okay, I will talk to you in the next video. Have fun making your poster.